Hello everyone. So this is a short demo of the CoreOS functionality. In this demo, we'll focus on etcd, systemd, and fleet. To start with, first we'll create a 3-node CoreOS cluster here, and I've already created the cluster. So this is my cloud config that I'm using for this 3-node cluster. So here, this specifies the discovery token. So I'm dynamically discovering the cluster here, and I am starting services etcd, flannel, and fleet. So these are the three services that I'm starting. So I've already done a vagrant up, and these are my three nodes that I've already started. So let's make sure the cluster is working by doing some basic tests here. So if we look at etcd output, we can see the three nodes of the cluster, and let's make sure we don't have any unit started, and just let's check the missions output, and this shows the three nodes of the CoreOS cluster. There are two service examples that we will try in this demo. The first one is like an hello global fleet service. So let's look at what this service does. So here we're just starting a Docker container, a Docker busybox container, which is in an infinite loop which spits out hello world here. And we are setting fleet metadata here to say global is equal to true, which basically would start this service on all the nodes of the CoreOS cluster. So to start it, let's do. So basically, this basically starts the hello global service, and let's look at the units that are started. Okay, since we specified that this is a xfleet global is equal to true, we can see that the service is started on all three nodes, and it is running fine. And we can look at the status of the service, and we can see the service is active, and this shows the std output. And we can do the same. We can go to some other node here, which is the node 3 here, and we can do the same here, and it is running here, and we can see even the Docker container here, which is running on node 3. The same would be the case for node 2 as well. So to demonstrate high availability, let's take a little bit complex service here. This is something called as two services that operate in tandem, and one service. Okay, let's look at the first service here. So this is a fleet service. So there are a few things that's interesting in this service. What we are specifying is this service would need etcd and Docker. So we are specifying that as a requirement, and this specifies the dependency here. So we say that this service has to be started after etcd Docker, and here we also say that this service needs to be present before the discovery service. Uh, so this is another service that this service works in tandem. So that is why we specify that here. And another interesting thing is, so here we are starting the service, and here we are using a template feature where the argument specified to the service is passed on to the percentage high that we see here. Uh, Another thing to note is we are starting the service in the foreground and not in the background, because for systemd to monitor Docker containers, we need to start the container in the foreground. And the last thing to note here is that we want to start this service, like when multiple instances of this service is started, we don't want to start that in the same node. So that is why we have specified that this conflicts with any other service which starts with Apache T. Uh, And in terms of what this container is going to run, this is an Apache web server. So this is basically specifies where the container image itself is present. Uh, and the other service that is works in tandem I was mentioning is this second service. So here again it has etcd as a requirement, but in addition to that it also says the main Apache service is a requirement for this discovery service, because the discovery service is monitoring the main Apache service. So there is no sense for the discovery service to be present without the main service. So we specify that as a requirement. And similarly, we specify the dependency as well. In terms of what this service does, it continuously does a curl to the main Apache web server. If the return is successful, it sets the IP address and the port number in the etcd as a key value store with a time to live of 30. So which means that at any point, if we are not able to reach the web server in 30 seconds, the etcd is going to remove that key value store from there. And the last one here is we say this discovery service should be triggered on the same unit where the Apache service is running. And actually this is like a diagrammatic view of what this is doing. There is a service, there is a sidekick service, this is Apache service, Apache discovery service, and this is updating etcd. So that's kind of what we are doing here. Okay, so now we have looked at what these services does. So let's basically start this service. So here I have started the two services. So I've used the port 8080 as an argument. So that means that this service is going to be started on port 8080. And here we see that this unit is launched on the third node in the cluster, 103. So it's active and running currently. So now if you go to node 3, if you look at the Docker output, so we see the Apache container is running. And let's see the status of the service itself. So we see the service is running. And we can see the final goal of this discovery service is that it is going to update the etcd. So first let's look at the discovery service is running. So it is running correctly. So now let's look at the etcd output, and we can look at that at any node. So we don't have to, because it's a it's a global distributed database. So here we see that this has updated with the node 3 IP address. And if we get what is the content of this, so we should see the service IP and the port number here. So this is working fine. To demonstrate the high availability, what we'll do is we'll go and kill the Docker container, and let's see what happens. So ideally, because we have specified the restart option in the service, this service should get restarted. So let's do this. So basically we stop the Docker container. So what this should do is, because the container is running within systemd, it should ideally restart the container. So we look at the status here of the service. Okay, so now it says it is activating. So basically it's going to do the activation after the restart timer. So if we look at the Apache service, so these are the options that specifies the restart. So here we are specifying always restart, and the restart timer is 30 seconds. So now let's look at, now the service is running, and so it has restarted. So here we have illustrated server's high availability. So now what we'll do is we'll do a node high, demonstrate node high availability. So let's restart node 3 and see what happens. So this is where the service was started on. So now we have rebooted node 3, and let's look at the units here. So now we can see that these two services have moved from 103 to 101, and now it is active and running. And now we can go to node 2 or any other node, and we can check if the HCD database is updated. So it takes like few seconds for the HCD database to get up. So now we see the HCD database is updated, and it shows node 101 here because the service has moved from node 3 to node 1. And so here if we see, now it shows the node 101 and the port number. So this is a application of very primitive service discovery and high availability using HCD, systemd, fleet, and Docker. Thanks for watching.